Hi, my name is Oded, and I'm a technical product manager at Wix, just like Sava, who will present himself later. And this is a continuation to Yuval's presentation about how to set a new microservice in 1 hour. So as Yuval showed before, here are all the nice concerns that Dana has to deal with in order to build a new microservice. And today I will focus on how we tackled some of them, the one highlighted in red. No need to memorize them. I will anyway go over them one by one. But FYI, although I will only focus on these ones, we actually have good solutions for all of these. Before we start and dive into the actual framework we build, some basic background about protobuf, in case you've never seen it, just because it's needed later on to understand some of the details. Protobuf is an IDL, basically a language for which I use to describe an API. So in this case, even without really understanding everything, it's pretty obvious, the laser doesn't work, never mind, that this API is about a product. The product has an ID and a name. These are its properties. There's an endpoint to get the product. So this is all the proto you need to understand for now. But there is a nice thing here, which is relevant, is that next to the name there is min length and max length. Kind of obvious. It means that this is the boundaries, or the string cannot be less than 1 character, not more than 80. Point is that when I look at the name property, I know a few things about it. I have some metadata, and that is helpful, as you will see later. So 2 years ago, this is what it looked like to develop a service in Wix. You want to start a service, so this one line to start it. You want to expose an API in Proto, like the idea is that you define it in Proto, although it wasn't always this way. So you just bootstrap the My API implementation, the implementation of the API, and there you go. You have a running server. Don't need to worry about all the details. It does work. Then you want to communicate with the world like doing an RPC, so not too bad. 3 lines of code. You just need to give this identifier of the service, and you can communicate with it. Lying a bit, because this is one way. There are 3 ways in Wix to initialize an RPC client, and you need to know what are you communicating with. Is it option 1, option 2, option 3? Build your client accordingly. But still, it's not like it's a 100 lines of code. Messaging queue. In Wix, we use Kafka, and in order to work with Kafka, we use a library that was developed by Wix called Ground. It's open sourced, and you can create a producer and consumer. Again, nothing too complicated. You create a topic, then you create a producer, then you can consume it in the same service, other service. It's simple enough. And if you want to conduct experiments, like stopping for 1 second, when I say experiment, I mean an A/B fork in your code where you build a new feature and your service is live in production. You want to say, OK, once I open this user or this group of users or whatever, they will go through the new flow. I will make sure everything is all right. So this is, at least in Wix, is very common. So we have, again, an open source library called Petri. And we use here, there's a feature toggle. This is the name of the class which I use for the fork. And yeah, 1 line and I'm good. And DB connections, so Wix didn't really have some good library to handle with the actual writing and reading from the database. You have to do this yourself with JDBC, but at least the connection layer is managed. So 1 line, and you don't need to worry about how to handle the connection and the resources. And there's actually more things to be taken care of, obviously. And so if every library is well written, simple, and easy to use, so what is the problem? You kind of seen it before, like with 100 readmes, because nothing is really that simple. But really, if we just look at what it takes to write an RPC, you remember I showed it was like 3 lines of code, but not really. So first, I know how to do it. You don't know how to do it, meaning you have to go to the README and learn how to do it. Then you need to, or you copy paste it from somewhere. And again, remember there are 3 options, and you don't know that. Okay, there's gRPC. There are 3 ways. And you sometimes need to read from some configuration file because you need to know where the service is actually in production. So you need to write this configuration file, configure it. You need to read from it in code. And well, you also need to test it, right? It's not enough to write production code. So you need to mock it. And you also need to test, so normal test, I will show it in a second, only test the business logic, but then you lose this code where you read the configuration and you create the client. You don't really test it, but you need to test it. Otherwise, maybe it doesn't work. So you need to write more tests. And then I will show the test in more details in a second. And you need to do this for every RPC. And you can take what I said, copy paste to each one of the concerns about the same ones that I showed earlier. So you do a lot of work around the wiring, although it seems like it's just one line and just one line. So here is what it looks like in very, very, very high level. I have this service class called some service. It gets everything as a parameter, the RPCs, the laboratory. This is the thing that conducts the experiments. And then I have some static. The object is in Scala. It's like a static thing. So I create all these production instances of the RPC, of the laboratory, of the Kafka, everything. I have all of them ready. Then I start my service and all good. So this is what my production code looks like. But I can't test it. So I'm basically repeating this on the left side with a test. So I'm doing the exact same code, but this time I'm creating a mock RPC, mock laboratory, mock for everything. And then I initialize my service. And by mock, I mean mocks that runs in memory. And now I can test all of my business logic, and I'm really happy. But then, if I go one slide back, I didn't test the upper part, where I created all the real production instances. I didn't even test them. So I'm basically forced to create another set of tests where I actually set up the service, and then, well, I test something. What do I mean by something? So I have this code that generates the wiring for the RPC. So I will choose some flow that goes for this RPC, and then I will make sure it doesn't blow up. Okay, that will prove that I wrote the wiring code correctly. So this is what it looked like 2 years ago, approximately. And what's the problem here is that developers focus on wiring code instead of focusing on business value. This is what we wanted to change. Okay, this is why it took 3 weeks to create a service that does absolutely nothing. So how can we even begin to solve it? We would start by actually talking to users. Like this was a good place to start because we had to get to this understanding that this is even a problem. So we would identify common concerns like all this wiring stuff and hunt the time wasters. And one thing that we quickly realized is for the infra to be efficient, we had to make it opinionated. So these are some of the decisions. It's definitely not all of them. So just to get the idea, we decided that with our infra, every service is responsible for a single entity. So if you have, like in e-com, you have orders and products, it's kind of obvious in this case. It's not always obvious. So one service would handle orders, another service would handle products. And even if you want to, you cannot create a service that handles both of them. Why? Because then it allows us to make certain assumptions about the infrastructure and create infrastructure which is much easier to use. And we recommend a certain way to test things. In Wix, we believe in API first, meaning that you create the API and then you build your system. So we also recommend to test everything in memory from the API level. This is how we tell people to test. And another very, very important thing, we tell people do not test the infrastructure. You work with a mock RPC client in your test, do your business logic. The RPC works, trust us. We do the testing for it. And you will see soon that you do not write all the wiring code. You're not responsible for it anymore. Therefore, you have absolutely no reason to test it. So how can we achieve this? First, move as much wiring code to configuration. Example, I don't want to initialize an RPC client. I just want to say that I wish to talk to that service. Okay? I intend to RPC to that service. You generate a client for me. I don't want to write this code. And once you have this configuration, you can validate it, meaning, OK, this service really does exist, and I can talk to it. And finally, I can generate the boilerplate code. So even if we did not eliminate, and we did not, the fact that we have 3 ways of communicating with Service Center Wix through RPC, that's OK now, because our infrastructure sees whether it's option 1, 2, and 3, and would generate the code for this client. So despite the complexity still being there, it's not my concern anymore. OK, so what does it look like? Just for the sake of explanation, we're looking at something called a basal macro, but it's not important at all. This is the metadata about my service. It can contain many more things, but I just want to focus on 2. So I have the name of the service, not really interesting. I have RPCs. This is what I explained earlier. my service wishes to RPC to a service called currency converter, which obviously converts currencies. And this is one. Second, I have this service equals some service API. It means that my service will implement the contract some service API, which was defined in protobuf. Okay, so this is the metadata about my service. This is, for the sake of example, everything that I need to tell the infrastructure. And now let's see what we can do just with this information. So first, I can basically generate the server and the interface to implement. And that's all I have to do now. I have to go and implement whatever APIs I define in the protocol for my service. So I would go and implement them. And notice this is possible because there is one entity per service. I have one service to implement, I implement it, and that's it. Another thing, since I said that I would communicate with the currency converter, we allow to create something called a context. You can see context builder.build. And then under the context, I have context.rpc.currencyConverter with autocomplete and everything. Okay, I don't have to worry about how this works. And I can communicate with the service as if it was a library. And don't forget that whatever I write, I also have to test. So we really try to provide the exact same experience we provide in production code, also provide it in test. So if before I had this context builder, so now I have the test context builder, and I get the same context. And I can, in my test code, I can just call whatever method that I want. And below, I can really easily take the currency converter, mock it. The mock is ready and wired to use. It uses Mockito for but it can use anything else. I will just say that it returns whatever, and then I will call the method on my service, and that's it. I don't have to handle with test setup at all, except the mocking for my own business logic, which I have to do. And just a reminder, this is what it used to look like before. Okay, so now I have this nice context and it just works. And previously, first I had to do all the contexting myself. Second, because previously I wrote the code that bootstraps the RPC, I had to do another layer of tests that set up the service. Now, you never have to do this. Like we tell developers, don't do this unless you're exploring. Okay, you're not sure how something works, fine, set it up, try what you want, then delete it. One more thing. So as I said, I have some API that I need to implement. I define the service. So I would write my business logic. But although I am just writing the business logic, before my business logic is even get called, the context is enriched, meaning that we add stuff like identity, so I would know who called me. And input validation happens before. Remember, because we work with protobuf, then we know a lot about the API. We know that name. I think that was the example, cannot be more than 80 characters. So if it's 81, I will fail the validation even before it hits my code. And I can do permission checks. Another thing that I didn't show, but on the proto level, you can say which permission is required in order to call this endpoint. So we can do the permission validation before it ever hits your code. And again, about being opinionated, you can't opt out from these things. You can't say, I don't want input validation. I don't want permission checks. You can't really opt out. This is how it works. About producing and consuming, we say, OK, since we decided that the service had a single entity, so we also decide that the events that you send into the world would always have the same format. You have created, updated, and deleted. And created, updated has the form of the entity that the service owns. We do allow to also define custom actions because CRUD events doesn't cover the entire universe. But producing is really easy. You call context the domain events. It's pre-wired for you. You don't have to do anything about it. And you send the ID and the entity. And actually, Sava will show later that usually you don't even have to write this single line because it can be taken care of for you. Testing, again, no problem. You have a pre-wired test that you can check whether the event was fired or not. Again, assuming that you even had to send it. If it was sent for you, you also don't need to test it. Consuming is easy. Again, it's declarative. It happens to be in proto. I say, I want to consume event from order transactions. So you just say it. You don't need to know if you are familiar with Kafka. There's the concept of topics. You don't need to know what a topic is. You just say, I want to consume these events. And then you get a method to implement. It's identical to the way you implement an endpoint in the service. And then you handle these events in code. Last, but I think it's the last one. Experiments, you declare that you intend to fork on some specification. Again, it's a point on the code that you want to do a fork in production, whether to go to new code or old code. You say, I intend to fork on this, and then wherever you want to use it, you make sure you call conduct, and you see whether you want to go left or right. So how did we do all of this? And remember, it was all from like a very simple idea that I write the metadata, then we validate it, then we try to generate as much code as possible. So first, we talk to our users. That's the most important part. We allow to do these things declaratively. So instead of writing the code, you declare what you want to happen. And we also took the testing very seriously. We created test environment just like we created production environment so that the test would be easy. And then we auto-generated opinionated code. Validation permission checks happen before your code. And if infra is responsible with the correct error codes, and you use test environment to test your logic, and you never test the infrastructure. And the result, happy developers that instead of working on wiring code and boring stuff, they actually work on business logic and provide value to the users.